We're in section 9.2 today, Pythagorean Theorem. I think you guys actually learned this last year. Do you remember a squared plus b squared equals c squared? So that's really, really important. You can go ahead and write down that formula. A squared plus b squared equals c squared. I have it down here, right down here at the bottom, next to algebra. All right, that's going to be our formula. You don't have to write down everything on this slide, but you do need to write down this triangle, okay? And don't make it so small that, you can hardly, read what you wrote, all right? So, use up, 4 or 5 lines. Draw this triangle, but more importantly, I want you to label each side of the triangle. I also want you to write down that in order for the Pythagorean theorem to work, it must be in a right triangle. Okay, it has to be a right triangle. It has to have that right angle. If it does not have the right angle, it is not, you're not going to be able to use Pythagorean theorem. Okay, so a right triangle is critical, otherwise we cannot use it. All right, so go ahead and copy down those terms. Okay, so in all of the examples that we're going to do today, we're going to use our Pythagorean theorem formula. A squared plus b squared equals c squared. All right, so just real quick, write down this triangle. And in all of the examples, we're basically just solving for different parts of each triangle. So sometimes A, sometimes B. In this case, we're going to solve for C. All right, and we're going to find the length of the hypotenuse. All right, so it'll be a squared plus b squared equals c squared. And remember what we said about the legs, okay? The legs connect. All right, so look up on the screen. They connect to form the right angle. So here's the challenge is, it's kind of hard to know, well, which one's A and which one's B. The good news is it doesn't actually matter as long as you choose the legs for A and B. The order does not matter. So for some of you, you might write 5 squared for A. Some of you might write 12 squared and then reverse it. Either way, as long as you have them both on the left side of the equation, it's okay. All right, now if you put one of them on the other side, it's going to be wrong. All right, so C has got to be on the other side. And in this case, I don't know C. All right, so here's where your calculators can really help you. Now, technically, you don't need them for this because we know what 5 squared is and 12 squared. What's 5 squared? 25. What's 12 squared? 144. We can do that. We can even add them together. All right, but the numbers are going to get large enough to the point where calculators are definitely fine and you can use them. And even the square root here. This is one of the perfect squares that we've memorized. Does anybody remember the square root of 169? 13. Yeah, very good. It's 13. So again, okay, so just as a review, so I probably just jumped a step here. How could I get rid of my exponent of 2 on the C? All right, so I have to get C by itself. Elizabeth, what am I going to do? I need to square root it, okay? So take the square root of both sides, and we just said the square root of 169 is 13. Now, something is different about this answer versus yesterday. Yesterday, if you remember, when we solved equations, our answer was positive and negative. You guys remember that? Anytime we solved an equation, our answer was positive and negative. But there's one very important reason why our answer is only positive when it comes to the Pythagorean theorem and actually what we are solving for. Why do you think my answer cannot be negative, Jace? Because it's negative. You can't have a negative measurement. There's no negative side on a triangle, okay? So every year I have that mistake happen where someone just says, oh, well, I solved an equation, so my answer is positive, negative, and they're in that habit. But you have to remember this is a measurement of a side length, and it cannot be negative. Does that make sense, guys? Does that make sense? Okay, so now I want you to try one. and compare your answers with your neighbors, your buddies. Okay, go ahead and try this problem with the given dimensions, all right, and solve for C. All right, awesome. So a squared plus b squared equals c squared. Technically, okay, so let's just go by show of hands. Who, sorry, I'm trying to pull it up and talk at the same time, and it's not really working well. What order did you plug it in? Who plugged in 8 first? Who plugged in 15 first? And we all got the same answer. Okay, so that's great. All right, so I plugged in 8 first. 64 plus 225 is 289. All right, and I just want to take a minute to talk about our answer, okay? The 17 feet, usually, and maybe you can kind of assume, you know, you literally can choose any number, you know, for your side lengths, and the odds that your answer actually works out to be a whole number are actually pretty slim on Pythagorean Theorem. Most of the time, your answer is going to be a decimal, and in that case, you're going to round it to the nearest tenth. All right, so I'll remind you of that on Friday and Monday before you take your quiz, but don't be thrown off on Pythagorean Theorem if you solve it and it's not a whole number. Most of the time, it's not. It's actually just, for these examples, it ends up being whole numbers repeatedly, but that's definitely not always the case. All right, so in example 2, the only difference here is we're solving for a different side of the triangle. Okay, so it's the same formula, plugging in the numbers. You're just going to plug them in different places, which does change how you're going to solve the problem. All right, okay, there we go. All right, so let's go ahead and write down the triangle and see if you can go ahead and plug in the numbers. Okay, so in this problem, we're solving for A. So A squared plus B squared equals C squared. We don't know A. Now, here's the important part for B. Which one is B, 2.1 or 2.9? It does matter. No. Listen to what I'm saying, guys. It does matter because the B number goes on the left and the C number goes on the right side of the equal sign. So if you get them backwards, you will get the wrong answer. Okay, so how do I know which side? Let's just go with B. How do I know which side is B, Sarah? It's not necessarily the bottom part, though, because that can throw you off depending on how the triangle is turned. Sherelle? I would not go by that rationale, but I see what you're saying. There's a clear reason, though, which one is B. It's connected to the right angle. Okay? So here's your right angle, and it's always going to be identified as the right angle. The other side that's connected to the right angle is always going to be A or B. Okay? And the hypotenuse is not connected to the right angle, and it's opposite from it. So you can't say it's on the bottom or it's on the top because what if it's turned, okay? So that's really important because if you put 2.1 on the other side, your answer will not be correct. All right, so now I have A plus 2.1 squared equals 2.9 squared. Before I can start solving, I must evaluate my exponent. All right, so what is 2.1 squared? 4.41. What's 2.9 squared? 8.41. And then, I just kind of gave it away, but what am I going to do now to solve for A? I have to get everything else to the other side. What would I do first, based on kind of what we did yesterday? Subtract 4.41 from both sides. A squared equals 4. And what's my last step to get rid of that exponent? Square root both sides. Why is my answer only positive? Why is my answer only positive? It would have been negative. It would have been negative if you had done it the other way. Okay? Why is my answer only positive? Elizabeth? You can't have a negative measurement. All right, very good. All right, guys, last example. Oh, sorry, we have to solve for B now. Just real quick. All right, we'll just take a minute to solve for B. It's just more practice. We solved for C, we solved for A. Let's solve for B, and then we'll have one more example. All right, guys. Okay, so 16 goes in for what? Hopefully we all got that part. 16 goes in for A or C? A. Yeah, it goes in for A. And then plus B squared equals 34 squared. We have to evaluate the exponents first. 256 plus B squared equals 1156. Subtract 256 from both sides, and B squared equals 900. Take the square root and you get 30. Okay? Take the square root and you get 30. All right, any questions? Any questions? Okay, so now example 3. Now, in example 3, they're basically tying it into like a geometry type concept. I know you're looking at like, oh, what is that? Well, it's a pyramid, okay? And you're going to see three-dimensional figures in the next unit when we're finding cubed roots. So I think it's kind of helping us bridge into section 9.3 also. Okay, so what you see though here is a right triangle within the pyramid. You see a height, you see the base, and then you see something kind of going up the side of the pyramid, and that's what we call the slant height, which ironically is also the hypotenuse in a right triangle. So instead of calling it the hypotenuse like we have in the first couple examples, now we're just calling it the slant height. That's it, okay? So it's still the same process. And they say find the slant height. Well, you're finding the hypotenuse because that's the side opposite the right angle. All right, so we're just going to plug them in. Technically, does it matter which number we plug in for A and which number we plug in for B? You don't have to draw this. Sorry, I should have started with that. Okay, no, it does not matter as long as you get A and B on the same side of the triangle. Okay, as long as you get them on the same side. The legs can be interchanged. All right, someone might put 4.8 first, and then someone might put 6.4 first, but as long as you have them on the same side, you're fine. One quick thing about your calculators that'll just save you a little bit of time. You can actually evaluate the entire left side in one shot instead of like splitting it. You can say 6.4 and then hit the x squared button underneath your circle button. Okay, and then just go ahead and immediately say plus, don't hit equals yet, 4.8, and then hit the x squared button again. So you can put the whole expression in there and then hit equals, and it'll give you the answer, okay, when everything's on the same side. So that's going to be 64 equals c squared, and just like we've done on the other ones, what do we do to solve for c? Square root it. Okay. All right, and very good. Any questions on that? Slant height?
So it's already going to have that little right triangle in there?
Yeah.
Okay.
Yeah. So the right angle, that's a really good question. The right angle is important because if it's not there, it could be 89.9 degrees, and you're not going to know. The box tells us it's 90 degrees without having to measure it. So the box will always be there, and that helps us figure out which side is which. Okay, so there's one more thing we need to go over. And it's, so in the first three examples, we're finding an unknown side. But there's also a scenario where you're given all three sides. Okay? And it says, and here's what the instructions are going to say, like on your quiz and test. It would say, do these side lengths form a right triangle? Do they form a right triangle at all? Okay? Well, if they form a right triangle, then they should be able to be plugged into the formula and both sides equal each other. All right? But the question is, all I'm given is three numbers. So how do I know which one's A, B, and C? If it does not specifically tell you, then 3, the first number is A, the second number is B, and the third number is C, unless it tells you otherwise. Okay? So let's just plug them in. 3 squared plus 4 squared, does that equal 5 squared? So now you're not solving for any side lengths. You're given them. You plug them into the formula. Does it equal out? All right. Does it equal out? What's 3 squared? What's 4 squared? What's 5 squared? What's 9 plus 16? 25. So it's yes. Okay. Yes. Yeah. So, all right. Very good question. And that's something that's confused people in the past. Like, how do I know? Like, is it in order or not? If all they give you is those 3 numbers, it's A, B, C. Okay. Now, sometimes they will say, this is A, this is B, you know, like not in a figure, but just list it. And then you just plug them in. Okay. All right. Let's do one more. Let's check 8, 9, and 10. All right, do these side lengths form a right triangle? So we're just doing basically the same thing all over again, just different side lengths. All right, so 8 squared plus 9 squared equals 10 squared. Well, what's 8 squared? 64. What's 9 squared? 81. And 10 squared is 100. So right off the bat, like, I know this is not going to add up, okay? But continue it all the way to the end. Don't just say no right there, even though you know. Go ahead and give me both totals and then just say no. All right? And if you understand that, that's everything you need to know for section 9.2.